have your packet open because you're going to follow along with me while we do these first two examples. And then you're going to work on the rest of these graphs with your teacher and your classmates. So the first thing we have here is we've got a graph of 1 over x. So we're going to just quickly talk about why the graph looks like that. So I'll make a little table over here, and I'm going to plug in some values. So the first number I'm going to plug in is going to be -1. If I replace x with -1, I get 1 over -1. So that's going to give me -1. If I replace x with 1, I'm also going to get 1, because 1 divided by 1 is 1. Now, what happens if I try to plug in 0? We talked about in the last chapter that you're actually never allowed to divide by 0. So we call that undefined. So what this does is it actually puts a restriction on your domain, because you just created a value, an x value, that you're not allowed to use. So that's why what we have are these dashed red lines. So the first dashed red line that comes from this restricted domain is the vertical asymptote. You have a vertical asymptote at x equals 0. That means that you have something in your denominator that causes a restriction on x. So that's why this vertical asymptote here is dashed in. Now you also have a horizontal asymptote here going across. That horizontal asymptote is coming from the fact that you cannot output 0 either. Anytime you divide by a negative, if the numerator is positive, you're going to get a negative. And anytime you divide a positive by a positive, you're going to get a positive. So you are now never going to output 0. So whenever we do these graphs, we're always going to draw in the asymptotes first. We're going to draw in the asymptotes first, okay? The vertical asymptote is going to come from the bottom of your fraction, and the horizontal asymptote is going to come from the outside of your fraction. Okay, so let's take a look at example 1. So when you look at this, 1 over x minus 3, I'm going to ask you, what x value causes x minus 3 to equal 0? Because you are not allowed to divide by 0. So we're going to solve this little equation down here, because that value in that fraction, in that denominator, cannot be 0. So if I solve this, if I add 3 to both sides, I have just determined that x cannot equal 3. That means that my vertical asymptote is the vertical line x equals 3. So when I draw that, I'm just going to dash in a vertical line at x equals 3. Now, there's nothing on the outside of this function. We could say that that's plus 0 on the outside. So there's no shift up or down, okay? That vertical asymptote shifts left to right, and a number on the outside is going to shift up and down. And we don't have that here, so that means that our horizontal asymptote is y equals 0. That's going to get dashed in right here. So now what we're going to do is we're going to plot some points. So I'm going to make a little table. I know that plugging in 3 is going to give me undefined. So I always like to put that on my table first, because I'm going to base my other points off of that point. So we're going to plug in 2 and 4. We're just going to surround that vertical asymptote. So if you plug in 2, you're going to get 1 over 2 minus 3. Now 2 minus 3 on that bottom, that's -1, and 1 divided by -1 is -1. If you plug in 4, you're going to get 1 over 4 minus 3. That's going to give you 1. So now I have a point at 2, -1, and 4, 1. So when I graph it, I'm just going to kind of follow my asymptotes there, pass through that point, follow, 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 pass through the point, like that. Your domain is everything except for 3, right? Because we decided that x could not equal 3. So our domain is from negative infinity to 3, union 3 to infinity. You can see that on the graph. I mean, if you follow along, coming from left to right, you're following, everything's okay until you hit that vertical asymptote, so x can equal 3, and then you pick up again after it. Same thing with your range. If you look at your range, you're not going to actually hit that horizontal asymptote in this case. So your range is everything except for 0. So again, you follow up from the bottom, following, you don't hit 0, then you hop over it, pick back up again, and go off to infinity. Okay? Let's try the other example here. So when I look at this, I look at that denominator because I first want to find my vertical asymptote. So that denominator, that's just x by itself. So what causes that to be 0? Just 0. Okay, so now I know that my horizontal asymptote is x equals 0. So now I know that my vertical asymptote is x equals 0. That actually helps me with my domain, because if I draw that in, really, without doing anything else besides that so far, I can say, well, the only x value that I can't have is 0. So I can almost write that domain as soon as I figure out where my vertical asymptote is going to be. Now, if you look on the outside of that fraction, you're going to see this plus 2. That plus 2 is considered a shift up. That's going to affect your horizontal asymptote. That means that your horizontal asymptote is going to be at y equals 2. I'm just going to dash that in right here. Y equals 2. Okay. Let's make a table. I always like to put my vertical asymptote in the middle and call that undefined, because then I'm going to plug points in around it. So I'll plug in -1 and 1. So now I'm going to get 1 over -1 plus 2. That's -1 plus 2. That gives me a positive 1. Down here, I'm going to get 1 over 1 plus 2. That's 1 plus 2, which is 3. So I have the point -1, 1 and the point 1, 3. Okay, and then I draw, following my asymptotes and crossing through those points. You can see your range is going to come from that horizontal asymptote, so that's negative infinity to 2, union 2 to infinity. Okay, everyone, good luck with your packet, and please ask your teacher if you have questions. Thanks.